Are the planets of Alpha Centauri habitable, or are we dreaming? For decades, Alpha Centauri has been the closest lighthouse in the vast ocean of the cosmos. With the confirmation of an exoplanet in the system, many dream of finding a new habitable world there, perhaps even a second home for humanity. However, scientists' discoveries seem to indicate that this exoplanet is not only unsuitable for life, but that it could be a complete inferno. But what does science say about it? Is there more than one planet in Alpha Centauri? And if there is, what are they like? Are they suitable for life to develop? Let's find out. Planet confirmation and detection. In 2016, the astronomy world was shocked by historic news. The existence of a planet in the closest star system to Earth had been confirmed. Its name is Proxima Centauri b, and it orbits the smallest and closest star of the Alpha Centauri trio, Proxima Centauri. The discovery of Proxima b was not a fluke or a clear image captured by a telescope, but the result of an exact technique known as radial velocity spectroscopy. The astronomers measured the small gravitational pulls that the planet exerts on its star as it orbits, causing minimal oscillations in the light that reaches us from it. After years of meticulous observations, the data left no room for doubt. There was a planet there, with a minimum mass of about 1.07 times that of Earth and an orbital period of only 11.2 days. This means that Proxima b completes a year, that is, an entire orbit, in less than 2 Earth weeks. Its orbit is so narrow that it places it extremely close to its star, just 0.0485 astronomical units, or about 4.5 million miles. By comparison, Mercury, the closest planet to the Sun, is nearly 36 million miles away. Proxima b is brushing against its star. This finding was a crucial moment for science, not only because of its proximity, but also because of the possibilities it implied. Unlike the thousands of exoplanets discovered tens of hundreds of light years away, Proxima b is just around the corner. If we ever traveled to another star system, this would be the first. But the most exciting thing was not only its detection, but the possibility that this planet is not the only one. Subsequent studies have suggested the possible existence of another planet in the same system, Proxima c, although its confirmation is still up for debate. The existence of multiple planets would significantly increase the odds of finding favorable conditions for life, especially if one is in the coveted habitable zone. However, the case of Proxima b is special. Not only is it one of the closest confirmed exoplanets, but it is also one of the most Earth-like in terms of mass. Its detection was the starting point for an avalanche of research on habitability, climate, atmospheric protection, and the search for biosignatures. In a way, Proxima b became the ambassador for potentially habitable worlds beyond the solar system. Location in the living area. One of the most exciting aspects of Proxima b is its location. Despite orbiting incredibly close to its star, about 20 times closer than Earth is to the Sun, it receives about 65% of the radiation that Earth receives from our star. This is thanks to Proxima Centauri being a red dwarf, a much cooler and dimmer star than the Sun. In terms of temperature and radiation, Proxima b is in what astronomers call the habitable zone. The habitable zone is that region around the star where the temperature allows liquid water to exist on the surface of a planet, provided that the right atmospheric conditions exist. And Proxima b is right in that range. Not so hot as to boil the oceans, not so cold as to freeze them permanently. But just because it's in that band doesn't automatically mean it's habitable. For a planet to truly support life, many additional conditions must be met. An atmosphere that regulates the climate, adequate surface pressure, liquid water, and perhaps most importantly, long-term stability. Proxima b seems to have, at least in theory, some of these conditions. Some models suggest that if it has a dense atmosphere like Earth's, or even something thicker, it could maintain surface temperatures compatible with life. In addition, its proximity to the star means that it receives enough light to have potential photosynthesis, although its spectrum is more inclined towards the infrared. Plants, if they existed, would be very different from those on Earth. They could have pigments adapted to that dim red light. But the key lies in a critical question. Does Proxima b have an atmosphere? And if it does, can that atmosphere withstand the constant onslaught of its star? Because being in the living zone is only the first step. Mars is also in that strip, but it lacks the pressure and temperature necessary to sustain liquid water in large quantities. Instead, Venus receives only slightly more energy than Earth, and yet it's a toxic and uninhabitable hellhole. That's why location is a necessary condition, but not enough. In the case of Proxima b, its presence in the habitable zone allows us to dream, but it also requires us to be rigorous. The next step will be to determine if its atmosphere exists, if it has survived the violent stellar attacks, and whether in some corner of its surface there could be liquid water feeding completely alien life forms or silent ecosystems waiting to be discovered. Stellar activity and atmospheric loss. Although Proxima b is ideally located within the habitable zone, there is one factor that could ruin all hopes: its star. Proxima Centauri, like many red dwarfs, is a highly active star. And when we say active, we are not just talking about sunspots or small outbursts. We are talking about actual cosmic storms, flares capable of releasing up to 10,000 times more ultraviolet radiation and X-rays than the Sun in its most intense moments. These flares are not isolated events. They are frequent, violent, and encompass the entire stellar surface. When one of these flares impacts the atmosphere of a nearby planet, such as Proxima b, the result can be devastating. Extreme heating of the upper layers of the atmosphere, dissociation of molecules, loss of essential gases such as oxygen or hydrogen, and even the complete ejection of the atmosphere into space in the form of a planetary wind. This poses a crucial dilemma. Without an atmosphere, there is no radiation protection, no thermal regulation, no liquid water, and no real possibility of life as we know it. So the big question is, how could Proxima b withstand this relentless bombardment? This is where a potential lifesaver comes in: the magnetic field. The Earth has a powerful magnetic field generated by its rotating metallic core. This natural shield deflects much of the solar wind and energetic particles, protecting our atmosphere and making life on the surface possible. If Proxima b has a strong magnetic field, it could survive attacks from its star. If it doesn't, their chances are drastically reduced. Scientists have proposed models that attempt to estimate whether a planet like Proxima b could generate a magnetic field of this magnitude. Factors such as its mass, rotation, and internal composition are key. Fortunately, Proxima b has a mass similar to that of Earth, which does not rule out the possibility of an active nucleus. However, being so close to its star, the exoplanet is most likely tidally locked. That is, always showing the same face to Proxima Centauri, which could affect the dynamics of its core, and with it, its ability to generate magnetism. And that's not all. The energetic particles and flares could also modify the chemistry of the atmosphere, generating toxic molecules or destroying compounds that might be necessary for life. Even if the planet has a thick atmosphere, it could be composed of gases such as carbon dioxide or sulfuric acid, creating an extreme greenhouse effect similar to that of Venus. Even so, not all is lost. Some more optimistic models suggest that if Proxima b's initial atmosphere was dense enough, it could have withstood these storms for billions of years. Additionally, the presence of deep oceans or active geology may have recycled gases and helped maintain some stability. Hey guys, just a moment before we continue. Don't forget to subscribe to our channel, clicking on the notification bell, and give us a thumbs up so you don't miss out on our daily videos. Tide and weather blocking. If Proxima b resembles Earth in mass and is in the habitable zone, could it also have a climate suitable for life? Here a crucial feature comes into play: the tidal coupling we talked about earlier. Due to its extreme proximity to Proxima Centauri, Likely, this planet is gravitationally coupled to its star in the same way that the Moon is to Earth. This means that one hemisphere of the planet is permanently illuminated, while the other remains in an eternal night. This phenomenon poses significant challenges to habitability. In a tidal lock world, the daytime phase could be scorchingly hot, while the nighttime phase would be frigid, with temperatures that could drop below permanent freezing. This extreme contrast seems, at first glance, incompatible with life as we know it. However, the most recent climate models paint a much more promising picture. Simulations by astrophysicists show that if Proxima b has a sufficiently dense atmosphere, similar or larger than Earth's, it could redistribute heat between the two hemispheres. Atmospheric winds and convection currents would act as a global thermal transport system, smoothing out extreme temperatures. Even more interesting is the role of clouds. In three-dimensional models, cloud formation in the daytime region, just below the point where Proxima Centauri's sun is at its perpetual zenith, could reflect a considerable portion of stellar radiation, reducing extreme heating. In turn, these clouds could collaborate with the atmosphere in maintaining a temperate zone right in the terminator, that is, the strip that separates the perpetual day from the eternal night. That terminator region, where the sun always stays on the horizon, is particularly fascinating. Some scientists have proposed that if life exists on Proxima b, that narrow belt of light and shadow could be the ideal refuge. There, temperatures would be more moderate, perhaps stable enough to maintain liquid water, and the balance between heat and lighting could allow for basic biochemical processes. However, all this depends on the planet having preserved an atmosphere and having the right ingredients: carbon dioxide at levels sufficient to trap heat, water vapor to generate clouds, and a surface pressure that allows for liquid. But if the atmosphere is too thin, the night side could freeze and the day side could become a burning desert. If it's too thick, the planet could end up similar to Venus. Another, even stranger possibility is that the planet has underground oceans, protected from extreme weather by a layer of ice or rock. In these scenarios, geothermal heat and internal pressure could sustain niches of life without the need for direct sunlight, as occurs in some extreme ecosystems on Earth. In any case, the climate of Proxima b is a delicate dance between light and shadow, heat and cold, stability and instability. And if there is a point of equilibrium, a strip of climatic habitability between two extremes, that place could be where life takes refuge. Future characterization perspectives. So far, everything we know about Proxima b is based on indirect techniques and theoretical models. We know it exists. We know its minimum mass, its orbit, its proximity to its star, and the potential conditions that could make it habitable or not. But to take the next step, to know if it has an atmosphere, if there is liquid water, or if it could even host life, we need to observe it directly, and that moment is approaching. Thanks to the new generation of space telescopes and specialized missions, we are on the verge of being able to characterize exoplanets in detail. One of the key instruments is the James Webb Space Telescope, the JWST, which is already operating from the Lagrange 2 point, nearly 1 million miles from Earth. With its MIRI mid-infrared instrument, the JWST can measure thermal emissions in the mid-infrared with unprecedented sensitivity. And why does that matter? By looking at how Proxima b's temperature varies as it orbits its star, we can infer whether it has an atmosphere, how efficient it is at distributing heat, and at best, whether there are hints of water or even patterns that suggest complex weather phenomena. If thermal measurements show that one side is much hotter than the other, that would suggest the absence of an atmosphere. But if there is a more balanced distribution, we would be looking at a functional atmosphere, and that is already a giant step. Beyond the JWST, the future is even brighter. Projects such as HabX, Habitable Exoplanet Observatory, and LUVOIR, Large UV Optical IR Surveyor, are being specifically designed to obtain direct spectra of exoplanets. These telescopes, with direct observation capabilities thanks to coronagraphs and perhaps even star shades, external structures that block the star's light to see the planets orbiting it, could do something revolutionary: analyze the chemical composition of Proxima B's atmosphere. And this is where the absolute dream comes in. Because if we detect certain gases, oxygen, methane, carbon dioxide, in chemical imbalance, we could be facing what is known as biosignatures. These are signals that, although they do not confirm life absolutely, suggest biological processes in action. The combination of these gases, in proportions incompatible with a purely geological balance, would be the best indication yet that we are not alone. We are on the verge of a revolution in the way we explore the universe. What seems like science fiction a decade ago is now being designed in laboratories and control centers. And Proxima b, because of its proximity and its potential, is at the center of this revolution. It may not be habitable. It may be a barren world battered by radiation storms. Or maybe, against all odds, it is the first planet outside our solar system to show us that life is not an accident, but a natural consequence of the cosmos. Although we don't have all the answers yet, Proxima b represents more than just a dot in the sky. It is a mirror of our aspirations, of our need to know whether life is a common phenomena or a rare miracle. Each technological advance brings us a little closer to that answer, and when we finally get a clear look at it, we may discover that the universe is much more alive and closer than we ever imagined. What do you think about the future of Alpha Centauri? Let us know your thoughts in the comments. And if you like this video, then you should check out this video on our end screens.